Welcome to my channel, IIT Foundation in Maths for 6th class students. Chapter 8, Geometry. We are doing the problems on concept application. Fourth problem. The sides of a scaling triangle are integers in centimeters. If the perimeter of the triangle is 15 centimeters, then how many such triangles exist? The sides of a scaling triangle are integers and the perimeter is 15 centimeters. Therefore, sum of the three sides must be equal to 15 centimeters and the three sides must be within 15 or 1, 2, 3 like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 like that. Scaling triangle means the three sides of the triangle are different. So if we take one side and 2 the other side, and the third side must be equal to 15 minus 1 plus 2. That is 15 minus 3, which is equal to 12. Therefore, if two sides are 1, 2, the third side is equal to 2. Let us verify whether these three measures can be the sides of a triangle. So, the sum of any two sides must be greater than the third side. Here the sum of these two sides 3 is less than the third side. Therefore, these measurements are not possible to have a triangular sides. Next, if we take 2, 3, then the third side must be 10, so that the perimeter is equal to 15. Now 2 plus 3, 5 is less than third side. So this is also not possible. Let us take 3 and 3, 5. Then the third side 7. So 3 plus 5, 8. 8 is greater than 7. Therefore, this is possible. Let us check the other rule also. The difference of any two sides must be less than the third side. Here 7 minus 5 is less than 3. 5 minus 3, 2 is less than 7. So 3, 5 and 7 can be the sides of a scaling triangle. One set. And another, let us take 4, 5 and 4, 5 and 15 minus 9, 6. 4, 5, 6. 4 plus 5, 9 is greater than 6. 4 minus 5, or difference between 4 and 5, 1 is less than 6. 4, 5 and 6, the difference is 1, it is less than 4. And sum of these two is greater than the third side. So this set of measures are also possible to have the sides of a scaling triangle. And next 5, 6 and 4 same. These are the same. Let us take some more. Let us take 2, 6, 7. The sum is 15. And sum of the first two sides 8 is greater than 7. 6 plus 7, 13 is greater than 2. 7 plus 2, 9 is greater than 6. And also the difference 6 minus 2, 4 is less than 7. Difference of any two sides must be less than the third side. 6 minus 7, that is difference between 6 and 7, 1. 1 is less than 2. 7 minus 2, 5. 5 is less than 6. Therefore, both the conditions were satisfied. So, the three measures can have the sides of a scaling triangle. Therefore, if we try all the combinations between 1 and 15 integers, we can have only these three sets to be the sides of a scaling triangle. Therefore, number of triangles that exist are 3. So answer is 3. Only these three sets of integers can have the sides of a scaling triangle. Next, fifth problem. In the given figure, the radii of the circles are equal. The radii of all the circles are equal. The middle circle is touching all the other circles and each of the other circles is touching exactly 3 circles as shown in the figure. The middle circle is touching all the circles at one point, and each of the other circle is touching 3 of the other circles. So this circle is touching these 3, and this circle is touching these 3. This is touching these 3, like this as shown in the figure. What is the total number of lines of symmetry that can be drawn for the given figure? 3, 6, 12 or many? So there are some lines are drawn already. Each of these lines are passing through the centers of 3 circles, and this is also passing through the centers of 3 circles, and this is also. These 3 lines are the lines of symmetry of this figure. So already there are 3 lines drawn in the figure which are passing the 3 centers of circles lying in a same line. So these 3 lines are lines of symmetry. Also we can draw some more lines of symmetry. See this is another line of symmetry. That is this is another line of symmetry. That is the line passing through the center of the center circle and the point of contact of 2 circles here, and the point of contact of 2 circles here, like this. This is another circle. This is another line. This is another. This is a line. One more line. Thus, there are altogether 6 lines of symmetry can be drawn to this figure. So total 6 lines of symmetry, that is option B is correct. So for this figure there are 6 lines of symmetry. 3 lines of symmetry passes through the centers of 3 circles which are in a line, and 3 lines of symmetry passes through the point of contact of 2 circles here and opposite 2 circles, point of contact of opposite 2 circles and the center of the central circle. Like that there are another 3 lines of symmetry. So altogether there are 6 lines of symmetry for this figure.